This Zoom session is being brought to you by the Fractal Water. All right. For today, 3.1 and 3.2, we'll be starting off the chapter 3. Since we finished 2 last time, that means you can start handing in next Monday, I believe it is. Let's see. Yeah, that 1, 2, 3, 4. That would be the October 4th. All right, so 3.1 is about quadratics and functions, and 3.2 is about polynomial functions. Okay, a quadratic function is the form ax squared plus bx plus c. And the simplest one is the function x squared, whose graph is this U-shaped curve called a parabola. You can see a parabola in the cable of a suspension bridge, or if you throw something through the air, it will go through a free fall trajectory in the form of a parabola. Back in the before times, when I did face-to-face the teaching, I would illustrate this by throwing an eraser across the room. See, that was a parabolic arc. All right, now, if it's ax squared, then the graph is still a parabola, which is either cup up or cup down, depending on the sign of a. If it's positive, then it's cup up. If it's negative, then it's cup down. Here's a graph of 1/2 x squared. Here's a graph of 1x squared. Here's a graph of 2x squared. Here's a graph of negative 1x squared. Here's a graph of negative 2x squared. Then if you do a times x minus h squared plus k, this minus h shifts the parabola over h units. This plus k lifts it by h units. So this point at the bottom or top is called the vertex point, h by k. Here I have a is positive, so this is the bottommost point. If a was negative, then the parabola will be upside down, and this would be the topmost point. If we start with f of x equals ax squared plus bx plus c and use completing the square, then we can write this as f of x equals a times x plus b over 2a all squared plus f of negative b over 2a. So this will have a graph whose vertex is at x equals negative b over 2a, and whose by f of negative b over 2a. Cup up if a is positive, cup down if a is negative. And that means that if a is positive, then this is a minimum value, and the minimum value of f equals f of negative b over 2a at x equals negative b over 2a. If a is negative, then it's cup down, and this would be the top. This vertex would be at the top of the graph, so the maximum f would be f at negative b over 2a at x equals negative b over 2a. So for example, here's a function y equals negative 2x plus 3 all squared minus 4. What's its vertex? What's its concavity? Well, because of the negative 2, it's cup down. And this x plus 3 you write as x minus negative 3. So the vertex is at negative 3 by negative 4. Here we have y equals 2x squared minus 4. Well, positive 2, so it's cup up. This is x minus 0, so it's y is 0 by this negative 4. All right. Here we have y equals x squared plus 4x plus 5. What's the vertex and the concavity? All right, and this is a 1x squared, so it's cup up. We'll write this to find the vertex. We'll look for x equals negative b over 2a. It'll be negative 4 over twice 1, which is negative 2. And when you plug in negative 2 into here, you get y equals 1. So the vertex is at negative 2 by 1, cup up. All right. Find the square and vertex and concavity. Complete the square and find the vertex and concavity. So here, y equals x squared plus 2x minus 3. To complete the square, we take half of the middle coefficient, get a 1. Square that, get a 1. Add and subtract into the expression. And get y equals x squared plus 2x plus 1 minus 3. These three terms complete a square of x plus 1. Minus 1 minus 3 is a minus 4. So y equals x minus 1 minus 4. X plus 1 all squared minus 4. Plus 1 is minus a negative 1. So the vertex is at negative 1 by negative 4. There's a 1 here, so cup up. All right, find the vertex of 2x squared minus 3x plus 4. Okay, first, and graph. Negative b over 2a is negative 3 over twice 2, which is 3/4. If you plug in 3/4, you get y equals 23/8. So the vertex at 3/4 by 23/8, and it's cup up. So you draw a graph, you draw the point 3/4 by 23/8, draw a u cup up through that, and here's the graph. Also, I'm perfectly willing to have you use some kind of graphing calculator to supplement this work. It's so much easier when you actually have a machine at your side. Here we have, okay, for this one, I had some really bogus problem where n is a number of objects sold and e is the, I don't know, the profit or something. It was a completely arbitrary formula, but we'll go anyhow. E of n is 2/3 n minus 1/90th n squared. And they want to know what value of n maximizes e and what is that maximum. Okay, we rewrite that as, oh dear. I think I've made some kind of error here. This should be a 90, not a 9. Excuse me. I'll have to fix it on the canvas. So 1, 5, 1 over 90. Okay, whatever. Well, anyway, negative 1 over 90 is negative, so it's cupped down. Oh dear. You know what? I'm going to have to change this all. If this is a 90, then this would be a 30, and this would be considerably greater. So I'm going to have to rewrite this whole thing. My apologies. All right. You'll be seeing a change in the canvas. Here we have some more interesting actual model. We have 2,400 feet of fencing to make a rectangular horse corral with dimensions x by y. What dimension makes a corral of maximum area, and what is that area? So we have a rectangle, dimensions x by y, area equals a. Twice x plus twice y equals 2,400, and a is x times y. All right, so if 2x plus 2y equals 2,400, then 2y equals 2,400 minus 2x, and dividing throughout by 2, y equals 1,200 minus x. And therefore a equals xy, which is x times 1,200 minus x. And after distributing and swapping the terms around, you get a equals negative x squared plus 1,200x. This is a negative 1 in front of the x squared, and negative 1 is less than 0. So it's cupped down, and the vertex is a maximum. The vertex is x equals negative b over 2a. That's negative 1,200 over negative 2, or 600. And going back from here, y equals 1,200 minus x, so y equals 1,200 minus 600, that's 600, and a equals x times y, which is 360,000. So the maximum area is 360,000 square feet in a 600 foot by 600 foot corral. All right.